Hello. This video will give you some examples of how to integrate using substitution. All right. We'll first start at looking at integration notation and do just one problem to remind ourselves of these basic rules of integration, and then we'll get into the a little more difficult stuff. All right. So let's look at the notation. All right. Again, a few of these rules you should know by now. It doesn't matter if the function is in terms of x or in terms of u, right? But what's important here is this dx or du. This notation is extremely important. This is the Leibniz notation, and it's extremely important. All right, it will make a lot more sense when we start integrating using substitution. All right, so we've got our symbol, our function in terms of, in this case, x, or in terms of u. And then we have dx. All right, and remember when we did derivatives, we had, dy dx. All right, so there's this dx is quite important. All right, so we're going to see u a little more when we substitute. Again, make much more sense when we get there. All right, so let's do an example using our basic integration rules. What you might want to do when you're starting out, just to feel good about this, you can chunk it up. All right, and what we're going to do is convert root notation to exponential notation. All right, and I just told you about the dx, and I did not put it. It's very important. All right, dx plus dx. Now, it's not multiply here. It's just the notation. That's all it is. Okay? All right, no problem. Again, if you want to look at this in an even simpler way and just deal with the variable, I can take our constant out. We saw that we could do that, right? No problem. So x squared dx plus 1/2 x to the 1/2 dx. And now when I look at this piece is easy, right? All right, those things stay, and I'm going to show each step. We add 1 to our exponent, and our denominator is the same as this exponent, no problem. Again, add 1 to the exponent, and the denominator is the same as that exponent. And now that you've applied this rule of integration, the rest is just algebra, so you really have to be thoughtful about how you proceed. Okay? Again, 2 plus 1 is 3. 3 divided by 3 is 1, so for that first piece, I just have x cubed. Plus, again, this is 3/2, correct? So I'll write that out. X to the 3/2 over 3/2. Again, when you divide by a fraction, remember, division is multiplication of the reciprocal. All right. Okay, 2 divided by 2 is 1. So when we integrate this, what we get is over, remember this is 1, so over 3 plus c, right? That plus c is quite important. And yeah, plus c. Again, if you want to check this, just find the derivative of this, and you would find that you'd get this piece. Again, always understand how you can check your work here. All right, no problem. Okay, so what if we have something like this, though? Right? I don't have plus or minus, and this is a little crazy, right? This should make you think about chain rule a little bit, right? We have a function, and then we've got to the x, and so on. But when we want to integrate, we're going backwards. So what we want to do is, the whole idea is if we could sort of convert this to something, a function in terms of u du. All right? And in this case, we're going to look for the inside function. That's what we're going to call u. All right? So I can think about this. I can say, wait a minute. If I had u to the 8th du, all right, my inside function is 3x cubed plus 5. No problem. All right. And if I find the derivative of that, again, I'm going to show this next step. You're probably going to skip it with enough practice, but when we find the derivative, right, that's du over dx. And what was the derivative of this, right? 9x squared plus 0, no problem. So I have this piece, 9x squared. And because, we can think of this as divide, right? So I can say du is 9x squared dx. Well, look at what we have here. Here's a 9x squared dx. What's nice, I'm giving you a nice example to begin with. What's nice about this is just a direct substitution. All right? And what I'm saying, what I said before, you're going to start with this. You're going to say, oh, okay, u is that. Find the derivative, and you're probably just going to go to here. Just showing you each step of how we get here, but you're probably going to say, oh, d of u is 9x squared dx. Ah, there's 9x squared dx. Fantastic. That's du, no problem. All right? So, let's derive this. And that shouldn't be that bad, right? That's u to the 9th over 9 plus c. Okay, now we substitute back, right? What's our u? Our u is 3x cubed plus 5 to the 9th over 9 plus c. All right? And I'd like you to take the time to find the derivative of this, and hopefully you're going to get 3x cubed plus 5 to the 8th, quantity to the 8th, times 9x squared, using the chain rule, right? Okay? All right, so take a little time and derive this, and hopefully you get back to this. All right, what about this one? This one's a little tricky, I think. And once we integrate tan, it's one of those, you're probably just going to remember it, all right? Because you might see it again. I don't have anything specific about tan, but we do know that tan is sine of x over cosine of x, right? Dx. And I guess the trick here is, what do you want u to be, all right? And again, it's just to make it a little easier, we could, if we want, sort of break this up. Yeah, do I want u to be cosine and then I have 1 over u? Or do I want u to be sine of x? And let's go through the motions, right? Let's suppose you said I want u equals sine of x. Then the derivative of that is cosine of x, right? And again, what we want is something like this: u du. Okay. So there's my u. du. And I need 1 over cosine. Sorry, I forgot my dx over here. I need 1 over cosine, right? I could bring cosine over by dividing. All right, and I've got dx, and I can divide by du. Okay, this looks promising. Okay, so I have 1 over cosine. So if I substitute that, I'll have dx du, right? Right, 1 over cosine equals dx du. And you're like, no, I can't have any x's, right? So this doesn't seem to help. All right, I want to integrate u du. And if I do this, I'll have dx du. So that's not really going to be helpful. I want something like this. All right, well, let's say we have u is cosine of x. Then the derivative of cosine is negative sine x dx. All right, and let's see what that would look like over here. If I have u equals cosine of x, then this is 1 over u. Okay, no problem. I need to figure out how am I gonna make this look like this? I'm hoping that's pretty easy, right? It's divide by -1 or multiply by -1, and I have negative du equals sine x dx. All right, that makes my life pretty easy because here's sine x dx. Excellent. And I only have du's over here. All right, fantastic. That's negative du. All right. Again, if you need to, right, that's really -1 over u du. Okay. And I can bring the -1 out if you want. Again, I'm just showing you each step. You're going to find your own shortcuts. Hey, and that should look familiar, right? The integral of 1 over u, to integrate 1 over u, that's the natural log of the absolute value of u plus c. Okay? This one we didn't want. All right, well, what's my u? All right, negative natural log of cosine of x plus c. All right. So again, maybe you're thinking, how would I know to do u is cosine? Why isn't u sine? Again, now that we're doing tan, you'll always know to put u as cosine of x. And if you forget, try it. And again, don't force a substitution, right? If 1 over cosine of x has a dx in it, and I only want du, then you can't do it. Try something else. Okay? All right, let's try another one. All right. Again, we're going to look for that inside function, and again, I'm going to, just to make things easier, I'm going to take my constant out, no problem. And I think it's pretty obvious that you're going to have u as 2x plus 7, so du is 2 dx, because it's an x. Okay, no problem. So let's see what we have. We've got sine of u, and I want a du somewhere over here. So how am I going to substitute dx? What's dx? All right. dx is du over 2, right? Just divide by 2. Fantastic. All right. And again, I'm going to bring my constant out. So I have 3 halves. All right, and now this is all right. Right? To integrate sine of u, that's negative cosine of u plus c. And don't forget to put back your u. Right? So that's 3 halves, negative 3 halves. Cosine of our u plus c. All right. Okay, and as you're going through practice problems and so on, and I said, if you want to check this, you could find the derivative of this function, and hopefully you get this. But also, there's some really neat, here's one integration calculator by Wolfram, and I could see if I'm trying to find the integral of 3 sine of 2x plus 7 dx, right? And there it is, negative 3 halves cosine 2x plus 7, right? It's a nice way just to check your work when you're working at home. All right. Well, again, I'd strongly suggest going through the problems, making sure you understand how did we decide what u is. Again, that inside function most times will be your u. This one was a little weird with tan because there's really no inside function. They're both valid functions, right? You try one, doesn't work, u is cosine, so just get used to tan. All right. But I think it's pretty obvious. I want sine of that inside function, sine of u. All right. and I need to have a du over here, right? Du over 2 or whatever. The next video will have other examples. Thanks for watching.